Hello guys. Welcome to this video on type checking in compiler, ensuring programming safety. In modern software development, even small mistakes can lead to serious bugs or system failures. In this session, we'll see how compilers help us prevent such issues using type checking. I am Yashashvi Kaushik from SRMAP section U. So by the end of the presentation, you'll understand three key things. First, what type checking actually is. Second, how compilers use it to detect errors. Third, why it plays a critical role in writing safe and reliable programs. Think of type checking as a safety mechanism that ensures your program behaves correctly before it even runs. So let's start with a simple example. We declare an integer variable x and assign it the value of 10. That's perfectly fine. But then we assume we assign a single string value hello to the same variable. Now this creates a type mismatch. If a program language didn't check types, this could lead to unpredictable behavior, crashes, and even security vulnerabilities. This example shows why checking is essential. It prevents such invalid operations from happening. So, what exactly is type checking? Type checking is a process of verifying the operations in program using compatible data types. Let's break down the flow. First, the programmer writes a source code, perfectly fine. Then the compiler analyzes this structure of code. After that, the type checker verifies whether all operations are valid in terms of data types. Finally, the compiler either allows successful execution or throws an error. In simple terms, it ensures that the data you use matches what operation expects. Why type checking matters? Type checking is important for several reasons. First, it prevents runtime errors by checking issues early. Second, it improves reliability, program behavior more predictable. Third, it ensures and enhances security by preventing unsafe memory access and type related vulnerabilities. And finally, it helps in debugging by providing a clear error message. You can think of it as an early warning system that saves time and prevent major issues later. So the types of typecasting. There are mainly two types of type checking: static type checking and dynamic type checking. Static type checking happens at the compiler time before the program runs, like C, Java, and Rust use this approach. Dynamic type checking, however, happens at runtime while the program is executing, like Python and JavaScript. Each approach has its own advantages and trade-offs, especially in terms of safety and flexibility. Excuse me. Static type checking. Let's look at static type checking, and here errors are detected during compilation time. For example, if we assign a string to an integer variable, the compiler immediately throws an error and stops execution. This ensures that only type-safe code runs. The advantages include early error redirection, more predictable behavior, better IDE support, and improved performance. Overall, static typing makes program safer and more robust. Dynamic type checking. Now let's look at dynamic type checking, and in this approach, variables can change types during execution. For example, a variable can first store an integer, then a string, and even a list afterwards. This flexibility is useful for rapid development and prototyping. However, the downside is that errors are only detected at runtime, which can lead to crashes if not properly handled before. So, while dynamic typing offers flexibility, it requires careful testing. Let's look at this working example. We define a function called add that takes two integers and returns their sum. We call the function with arguments 5 and a string 10. Step 1. The function expects two integers. Step 2. The compiler checks the arguments 5 is valid but 10 is a string. It's not valid. Step 3. The type checker detects the mismatch. As a result, the compiler throws an error and prevents execution. The key takeaway is that type checking catches the issues early, avoiding potential runtime problems. Application in programming safety. Type checking plays a major role in programming safety. It prevents crashes caused by invalid operations. It avoids unsafe memory usage. It reduces security vulnerabilities like buffer overflows and type confusion attacks. And it ensures data integrity throughout execution. This is especially critical in systems like banking, healthcare, and aviation, where reliability is a must and non-negotiable. To summarize the whole video, type checking ensures that data types are used correctly. It can happen either at compiler time or runtime, and most importantly, helps build safe, reliable, and secure software. Now let's quickly test your understanding. I'm gonna give you three questions like a quiz. You have to pause the video and answer them yourself and check if you answered it right. So here are the three questions. First, what is type checking? Give me a short or 1 mark or 2 mark answer. Second, what does static type checking? When does static type checking occurs? And third, which languages use dynamic typing? Take a moment, give yourself the answer or write it down on your paper. Here are the answers. Pause the video if you don't want to know the answer beforehand. And here goes the answers. Type checking is a type verification answer for the first question. And now goes the second answer. Static type checking happens at compiler time, as do the dynamic checking happens at runtime. So, and for third question, which is which language uses dynamic typing, like an example. So Python uses the dynamic type language. It checks the errors at runtime. So if you get this right, great job. Keep going, and please like the video, share the video if you like it, and subscribe to the channel and get my updates as soon as possible. Thank you. Signing off. Yashashvi Kaushik.